Hey guys, welcome to the new video. I've made some changes, right? In the previous video I was like reading from a sheet and then explaining you the question. But this time, what I've done is I've taken a screenshot of the question and I've pasted it on the PPT so that you can read it and solve alongside, right? So let's just start. So today's question says that. Let me just check if it's recording. Yes. So the question says that example 5.42. Wait a minute. Right. So the question says that the joint PDF of two random variables x and y is given by fx comma y is equal to k, where y lies between x square and x, and x lies between 0 and 1, and the joint PDF is 0 otherwise. Find, the first part says that we need to find k, the second part says that we need to find the marginal PDFs of x and y, third part says that the conditional PDF of x given y is equal to y and of y given x is equal to x, right? So let's just start. This is a very basic question, right? So the first part, what I need to do is I'll just integrate the joint PDF over the limits of y and x, and I'll equate it to 1, right? So basically the area under the curve should be equal to 1. So my PDF is k, and let me take this as dy and d and this as dx, right? So I am assigning this first integral sign to y and the second one to dx. And why am I doing that? I am doing this because the limit of y is in terms of x and the limit of x is in terms of 0 and 1, right? So if I take x to be as 0 and 1 on the integral which is on the left hand side, the left hand most integral, if I take it as representing the limits of x, then it will be better, right? And it is standard rule, you have to do that, right? So my limits of y, this is of y, this integral sign is of y, and this is of x, right? So x lies between 0 and 1 and y was lying between x square to x, right? So this will give me 0 to 1 ky, where y lies between x square and x dx. This should be equal to 1. This is equal to 1 because this is the area under the curve. So this will give me k is a constant term, so I'll take it out from 0 to 1, and if I put in the limits in place of y, I'll be getting x minus x square dx, right? So this will give me, and this is equal to 1, so this will give me x square by 2 minus x cube by 3 from 0 to 1. This is equal to 1. So this gives me k into 1 by 2 minus 1 by 3, which is equal to 1, which gives me k into 1 by 6 as 1, and ultimately k is equal to 6. Very basic question, right? So the first part is done now. Now we need to find the, let me just show you guys, you can read the question. It has become very easier, much easier for you guys, right? So we need to find the marginal PDFs of x and y. So the marginal PDFs of x and y. Marginal PDFs of x and y. So basically we need to find fy and fx. So let's just start by finding fy. And the rule for finding fy says that for finding f of y, the marginal PDF of y, we need to put in the limits. We need to integrate the joint PDF over the limits of x, right? So we'll be getting the marginal PDF of y, right? Now we know that our limits of x are 0 to 1 and our limits of y are from x square to x, right? So there's a rule in marginal PDF, right? If I integrate this function from 0 to 1, I won't be capturing the whole effect of the marginal PDF of y. Why? Because from this second limit of y, I can transform the limits of x in terms of y. And if I do that and plug in place of the limits of x, I'll be capturing the whole effect of the marginal PDF of y. So what I'll be doing is my y lies between x square and x, right? So basically what I can do is my x square is less than y from this let me just go right. So we need to find fx 6 dx, and we are trying to figure out the limits of x, right? So to capture the whole effect, I would be converting the limits of x in terms of y. So I have x square y x, and I have x lying between 0 and 1. So what I'll be doing is x square is less than y. This implies that x lies between, if I take the root sign, I'll be getting x lies between root y and minus root y, right? And we are also given that y is greater than x square, and any term which is greater than the square of another term will always be positive, right? So x square is always positive. We know that x square is always positive, and we know that x square is less than y. Therefore we can imply that y is greater than 0. Let me just explain you guys again. X square was less than y, therefore x lies between root y and minus root y. Now what I can do is so what I can do is I can just show you guys. So x square is greater than equal to 0. Why? Because a square of any term is always greater than equal to 0. Therefore this implies that because x square is less than y, this implies that y is greater than 0, greater than equal to 0. Therefore y is always positive. Y is always positive. And the second term that I can include is y is less than x, right? So the second part of the limit says that y is less than x. This implies that my x lies between my x, because it was less than root y, x is less than root y, but at the same time my x is greater than y, which means that my x lies between y and root y. Let me just check once. So my x square was lying x square, y was greater than x square, right? Right. So my x lies between root y and minus root y. My x is greater than root y, and my also you can have this question that why am I not including this limit? Why am I not including minus root y, x less than minus root y? Why am I not including this, right? So we know that y is positive, therefore y is greater than minus root y, obviously, because y is positive and minus root y is negative, right? Therefore I already have this limit, x is greater than y. So if I try to include this limit, if I try to include this part, I would be ignoring this part, right? I would not be capturing the whole limit of x. That is why I will be including this, because y is greater than root y, minus root y. And also this doesn't mean anything, right? So when I say that x is lying between minus root y and root y, and if I include this part, that my x is greater than minus root y, and we also know that y is less than x. Both of these can't be true. Both of these can't be true at the same time. We are given this, that my x, we are given that my y lies between x square and x. From this part I can conclude that my x is greater than y. But from this part, by opening x square less than y, I'll be getting x lies between minus root y and root y, right? And we already have that x is greater than y. X is greater than y. Therefore this must be false. Why? Because x is obviously greater than 0, right? And we were also given when we were given the limits of x, we were given that x is greater than 0. Therefore, we can't include this limit. I mean, obviously, if x is greater than 0, it is already equal to minus. If x is greater than y, x is automatically equal to greater than minus root y. This is true. Because this is true, this must be also true, right? But while writing the limits, I would take the part which is the most compact for writing the limits, right? So I would be removing this. I hope you guys got an idea. I tried to explain it in different ways, but once you try seeing the video again or try solving this on your own, you'll be getting an idea. You can also put in a comment if you didn't understand this. I would be explaining this again, but this was a little bit tricky, right? When I was studying, I also had a lot of doubts regarding this, but with practice I learned a little bit about this, right? So if you have any doubts regarding this, I'll be explaining this again, how to put in the limits on integrals. So finally, for finding f of y, I have 6 dx, and this lies between root this lies between y and root y. So this gives me 6x, where my limits are y and root y. So finally, I'll be getting f of y equal to 6 root y minus y. Right. So now we need to find f of x. Finding f of x, I need the limits of y. So 6 dy. So we know that x lies between 0 and 1. And my y lies between x square and x. So I need to find the limits of y. We are already given the limits of y. Y lies between x square and x, right? So we are capturing the whole effect by including the limits in terms of x. So we just need to solve this. This is pretty easy. So f of x is equal to 6y, where my limits of x are between x square and x, which gives me 6x minus x square, right? So f of x is 6x minus x square, where my x lies between 0 and 1. Now I didn't write the limits of y here, right? So we know that I need to just check this again. We know that my y lies between x square and x, and also my x lies between 0 and 1. Therefore my y is less than 1 and must be greater than 0. So my y is also between 0 and 1. When I'm writing the PDF of y, I need to write its limits, right? So finally we have got, I'll be erasing this, right? I'm erasing this just so that I have a clean page, right? Or I can just draw a line. Wait, let me not erase this. I'm just drawing a line, right? So we have found out we have our f of x as 6x minus x square, where my x lies between 0 and 1, and I have my f of y, where my y lies between 6 root y minus y. And we also know that probability is always positive, right? And we also know that root y will be greater than y when y lies between 0 and 1. Right, so our third part now says that we need to find the conditional PDF of x given y and y given x, right? So conditional PDF of x given y, f conditional y is equal to y, and the formula for this says that f of x intersection y comma f of y, or I can say that f of x comma y comma f of y, which means fx conditional y is equal to f of x comma y was 6 upon f of y was 6 root y minus y, 6 root y minus y, which gives me 1 upon root y minus y, where my x lies between 0 and 1. Because we are finding the conditional PDF of x given y, that's why I'm writing the limits of x. Now for finding the conditional PDF of f of conditional PDF of y given x is equal to x, I need f of x intersection y, which is the joint PDF of x comma y, of x and y. So this is fx, so this is fx comma y, the joint PDF divided by f of x. I have discussed this in the previous videos, you can check that out again. So this gives me 6 upon f of x was f of x is 6 into x minus x square, which is 1 upon x minus x square. F of y x is equal to x, f of y x is equal to x, f of y x is equal to x, where my y lies between 0 and 1. So you've solved all of the parts, right? So this was a very short video. I'm going to make short videos only from now on. I feel that more and more people, if I make a shorter video, more and more people feel like watching it. So that's why I stick to that only. But my frequency of uploading my videos will go up, surely. So earlier what I used to do is I used to take some long questions and I used to solve them for an hour or so, but that is not pleasant to watch by everyone. That's why I'm sticking to making short videos. Let me check my answer once. Let me check my answer from the book. Shall I open it? So this is the book that I'm referring to, right? I've talked about this book in my first video, my introductory video, right? So let me just check my answer, see if I've made some mistake. So k was 6 and f of x was 6x minus x square, y lies between 0 and 1. F of x conditional y, yes. But what they have done is a little bit different, right? So everything that we have done till now is correct, absolutely. But what they have done is, while writing the limits of x conditional y and y conditional x, they have done something different. What they have done is, in the book, you can also do that, but you can also use this, but it's better that you follow the book. The way that I have written the limits, in a lot of questions they have used this method only, but because they have written a little bit different for this part, I'll be just writing that, just explaining you that, right? So when they were talking about f of x conditional y, what they have done is they have simply converted the limits again, what I explained to you previously. What they have done is they have written the limits of x in terms of y only, like we did while writing the limits of, while calculating the marginal PDF. They have done the same. So what they have done is they have represented the limits of x as x, where root y between, I need some space. So what they have done is they have written in terms of y, and they have written x lying between 0 and 1, which is the same thing only. If you write x lying between y and root y, if you write x lying between y and root y, and then you write that y lies between 0 and 1, that and x lying between 0 and 1, both of these things are the same, right? So what we had done previously, what I had written previously, was also correct, but I am just writing for the sake that you guys don't get confused if you open the book, right? So f of y conditional x, again, what we need to do is we are writing the limits that were given to us. So y was lying between x square and x, y was lying between x square and x, and at the same time x lies between 0 and 1. They have written it like this. Again, that means the same thing. Right, yes. I hope you guys like the video. If you have any doubts, just let me know. Let me know in the comments. I'll be, uploading another video. I'll be also trying to attach the playlist. I'm not doing in this video. I'm not attaching any playlist, but in the upcoming videos, what I'll be doing is I'll be attaching a playlist of some of the creators on YouTube, some of the teachers that have taught integral calculus and how to establish limits while calculating, while solving this double integrals and triple integrals. I hope you guys will see that video and try to learn a lot from them. I also saw the same videos, right? So you'll be getting a better idea of how to set up the limits while solving these type of questions. I hope you guys like it. Again, if you have any doubts, just put in the comments and I'll be uploading another video. If you have any doubts in this video, I'll be uploading another video to explain those doubts again. And thank you for watching. Please share, please like, and please subscribe. Bye bye.